Reload that. Said it's live. Okay, and it is. All right. What am I doing? Yeah. Yeah, okay, I thought I decided to fix audio when improving audio synchronization. Because right now, I was thinking about this yesterday while at work. Because the way I write to, I'm surprised it works at all, to be honest. Because I write buffers of sound, basically. Yeah. I don't know. Maybe I don't want to switch to the sync API. Alright, yeah, I'll figure this out after. So let's look at this, day 18.
Okay, if John is done, that means we should go ahead and start here. 3 minutes, that was not too long to wait, I think. I'm pretty excited about John's new language. I hope you guys are too. It's the first time I've seen anyone who really cares about the same sorts of things that I care about try to make a new language. And so I'm pretty optimistic. I think maybe a year or two from now I can do Handmade Hero in JAI or something fun like that. I think that'd be a blast. I'm sure there's a bunch of cool stuff we could do with it. Anyway, thank you.
I think this was in 2015. Is it out yet? Not really looked into it. Oh, okay, it's just a thread. I don't think they have a website, do they? No idea.
For indulging me and waiting the extra few minutes. I wanted to catch the whole thing of John's presentation. But it is time now for day 18. Am I correct, people? I believe it is day 18 of Handmade Hero, the show where we create an entire game, professional quality, from scratch, no libraries, no nothing, so we can see how every last little thing actually works. And to me, that is very important because I think it's crucial to really kind of understand how everything works. Even when you do then go on to use libraries or use engines, just having that full perspective there that lets you at any time drop down to a low level and fix anything that you need to, or to understand why something might be going wrong in code that you're using. That kind of stuff is just so valuable. And so we are going to do it all here on this stream. We're going to keep on making sure we go into detail every last little place we can. So today on our, we've got a pretty big to-do item that we've got to do today, and I don't know if we're going to get it all in today, but we're going to try. And basically what we have to do is we have not actually done the work to make a proper synchronized timing loop to drive our game. So we could go ahead and make our game on the platform layer that we have now, but we would be at risk of having greater audio latency than we should have. We would be at risk of sort of having just synchronization problems there. We just haven't quite gotten to the point where we really understand the timing of when things show up on the screen and when the audio plays out the speakers. And so I'd like to do a little tightening there before we even start. I know I've said later that we're going to go and have a pass on the Win32 platform layer when we're going to ship, where we do a bunch of things that we've been putting off that are performance kind of stuff, that sort of thing, and compatibility stuff that we're not addressing now. But this I want to address sooner rather than later, because all of the decisions that we make in the actual game itself are all driven off of this timing. So when we are playing the game, when we are deciding how long things should take in the game, every last thing we do is going to be based on excuse me, is going to be based on whatever that clocking is. So if we have that clocking wrong in the platform prototyping layer that we've got now, then we're at risk of making a whole bunch of tuning things incorrect in our game. And then when we go to finalize the platform layer and tighten all that stuff up, then we have this problem where, oh, now all the tuning values, all of the stuff that we tuned in our game and all of the stuff that we thought was right for playability of the game as we were developing it is actually all wrong. So what we want to do is just take a little bit of time now to go through and kind of make it a little more coherent, what it's trying to do, and make sure that we understand that so that we can know that we don't have any critical problems that will lead us to make a bunch of bad decisions that we have to kind of redo later. Anyway, someone on the stream said don't forget to start recording. The problem there is I did forget to do the start recording, so that just means it's really just a convenience feature for me. It just means that I have to go through and take the file and just clip out the first little bit before I upload it to YouTube, so that the YouTube archive doesn't have a bunch of me watching John on the stream. Although, who knows, maybe it should be a bunch of me watching John on the stream. But, ignoring that. So, what we need to do today is we need to go take care of that. So, if you have pre-ordered the game, then you have access to the source code. You got an email that has a link in it. That link allows you to download the source code every night. So, I highly recommend you do that, because if you would like to follow along with what we were doing today, here on day 18, you just unzip the day 17 piece out of your zip file. That zip file has every day's in there, so you can jump to any day you want and work on it. So if you're looking at this video, you want to be day 17 source unzipped. That is what I am starting with, and that is what you should start with as well. All right, so before we go and actually do any coding, what I want to do first is take a look at the goals that we have for what we're trying to make. I want to really kind of go over sort of the high level picture so that everyone understands what we're trying to do. Now, I took some recommendations from folks and I downloaded this package called Smooth Draw, which I guess is something that they use on Khan Academy or something like this, just to see if it's any better than the thing that we were using, the Paint, Microsoft Paint. I tried it a little bit, and honestly, it doesn't seem to actually be any better. It seems to be basically just the same thing as we had before here. It doesn't actually seem to be all that much better, but you know what? We'll give it a little shot, and we'll see how it plays out. So, what I want to talk about is I want to go back to that diagram sort of that I've been using for quite some time, where I'm talking about the various frames, when they're computed, when they're displayed, that sort of thing. So I'm going to make some tick marks on our timeline here, like this, and basically what we have here is this is t going forwards. This is time. This is our timeline, right? And the timeline, you know, can I get that a little smaller? Timeline. Did that get smaller? It didn't feel like it got much smaller. I don't know. Did you guys think that got smaller? Hard to say. Let's go even smaller than that. Timeline. You know what? This is just not very good. I don't know about this program. We'll give it a little more. We'll give it a little more time, but I'm not optimistic that this is actually, good. Yeah. What can you do? Something we can address a little later, perhaps. Anyway, basically, if we take a look at what happens here, we start the game at some point that we'll call T0, right? And basically, this is when the game actually begins running. So the person runs the executable, and we got to do our Windows startup stuff and all that sort of thing. Now, at some point, we actually start the timing. So we actually take a look at what our timer value actually is, and that was query performance counter was the thing that we were using to measure time. We're going to take a look at what that timing value actually is. And when we take a look at that, that first timing sample we take is going to be the first benchmark that we have for figuring out how much wall clock time has elapsed during our code. So I'm going to call T0 that actual time. That is our first look at query performance counter, right? That's our T equals 0. Now what's going to happen there is during this first interval, during this interval here, right? During that first interval, we are going to be displaying essentially nothing, right? This is just plain blackness on the screen. We will, if anything, we just have a cleared window. There's nothing there because we have not actually prepared any actual anything really. We haven't actually got a frame buffer that we can show. So extending backwards as far as time goes is some sort of blackness, and then there's going to be some tick mark that's the first tick mark where we actually display a frame. Now if we want to, we can also call this T0. It depends, this is again, we're going to have a bunch of decisions here. We have a bunch of decisions. We could also call T0 the first frame flip, right? We could call it here, right? So I don't know which one we want to call T equals 0. We could call it the start, we could call it here. Hard to say. Something we're going to have to decide in a few minutes. But basically at some point during here, inside here, we are computing frame 0, right? We are computing frame 0, audio and video, right? We've got both of those coming online. So we're doing the computation work inside this time interval to compute those. When they are done, we will then flip them so that right here and coming forwards to here in this interval, you can actually see frame 0 displayed. So on the screen, you will see frame 0, right? And ideally, what we'd also like to do is have audio 0 show up right along with that, right? So we want audio 0 to come right here as well, right? I don't know how you guys feel about slashes through 0. Sometimes I feel like it's a little classy, you know? It feels a little European, a little fancy. So maybe I'll just go ahead and put that in there. Put that in there. So, what we've got now is we've basically got a time interval. This could have been as long as we wanted, right? Because blackness is on the screen and no audio is playing. So this is silent blackness, right? Sounds like some bad sci-fi movie. Silent blackness is here. And then once we start here, we have both audio and a frame on the screen. So what basically happens is this can be arbitrarily long. This time interval is arbitrarily long, and we don't actually care how long it takes. It could take an hour. Well, I mean, we care about that because we don't want to keep the user waiting, obviously. But it doesn't matter how long it takes because there isn't anything actually being displayed. So as far as the user knows, they're not going to see any glitches or hear any glitches if this takes too long because there's actually nothing going on. It's just starting up. The window has just come on screen. But once we get to here, this now we actually have some target for the amount of time that this is going to be on the screen. This is basically a fixed duration here, right? Oops, that's not very good. This is basically a fixed duration that we have to compute the next frame. Now, I want to really underscore why I say this is fixed duration, because there's a lot of stuff, like, I don't know if you guys have seen, NVIDIA has made some announcements, and there's been announcements on like other standards and stuff about variable frame rate displays, right?
Yeah.
Excuse me. Basically, normal monitors, excuse me, like the kind you would normally see from just today, normal monitors have some frame rate that they update the image at. And so that frame rate, whatever the monitor is updating at, is also what we would like to update at. if the monitor is refreshing the image, right, at 60 frames a second, so that's, 16 milliseconds or so, 16.6, something like 17 milliseconds a frame, right? If you think about that, we want to synchronize with that presentation, because if we do something other than 16 milliseconds a frame, then we will essentially be off beat with the monitor. So if you imagine the monitor has kind of a timeline down here as well, if it was updating at a different rate than we were, let's say a little bit less, like this, right? Of course, I don't know if I can get that out of my head. There we go. Basically what will happen is eventually we'll miss a frame. So right here it won't matter. Here it will display this frame. Here it will display this frame. Here it will display this frame. But here it will display the same frame again, the monitor will. And we'll have to wait till a much longer time than the user has used to been seeing. It's used to seeing this interval. Now it's going to see this interval. And we're going to see, we feel like we skipped a frame to the user. So we want the monitor's refresh rate and our refresh rate to be the same, right? We want to update at roughly the same frequency so we're consistent, so that every time the monitor goes to get a new frame, we give it a new frame. That's the goal. So we can do that on either the monitor's actual refresh rate, like let's say it's 90 hertz or 120 hertz monitor. We can do that at actually 120 hertz, or we can do it as some subdivision of.
Does that mean 120 frames per second? I'm guessing. Yeah, makes sense.
So let's say we're updating our game at 60 frames a second, and the monitor is 120 frames a second. 120 hertz, 60 hertz. Hertz is just cycles per second. Well, as long as we're a multiple of 2 or something, an even multiple, 3, whatever, away from that, then we know that we're never going to hit that beat frequency problem where we're going to have problems of skipping a frame as far as the monitor is concerned and having the user see a apparent change in animation speed. Sorry. I made some homemade almond milk today, and I didn't do a very good job. It's kind of rough, and it kind of scratches your throat a little bit. I don't know how to fix that exactly. I gotta think about it. I'm still new at making almond milk, so yeah. What are you gonna do? It's not the store-bought brand. So, all right. Basically, what I wanted to say about that is that there's a lot of talk now about variable refresh rate monitors, and basically what those are monitors that can update at whatever frequency you want, for the most part. So basically, what happens is whenever your frame is done, you just say display the frame, right? And so you might say, well, why do we care about any of this? Isn't the future going to just be you take as long as you need to display the frame and then you display it? Isn't that fine? And I don't understand the attraction of that. To me, that just sounds absolutely awful. I do not understand why anyone would ever want such a monitor at all. And the reason that I say that is because I feel like it always forces you to be completely wrong with how you displayed your animation. And the reason I say that is because imagine how the computation cycle goes on one of these variable frame rate monitors. Well, I come down here, right, and I'm basically saying that I'm going to use a variable frame rate. So it looks something like this. Who knows what it looks like. Let's say it looks like that, right? So we've got something here. Let's say this is going to be, something like 30 milliseconds. This is going to be something like 16. This was like 20, right? And this was back to 30 again. So we have a completely variable thing here. So what happens? We know that 30 milliseconds has elapsed. These are milliseconds here. We know that 30 milliseconds has elapsed between here and here, right? Something was on the screen here. We don't know what it was. We're saying this at some point in time. So it was with the previous frame. Who knows what happened? So let's talk about starting here. Well, we know that the world updated 30 milliseconds between here and here, right? We know that 30 milliseconds of time has gone by. So we need to tell the physics engine for whatever frame is that we're going to display right here, we would want to tell it 30 milliseconds, because there is a state of the world here, right? This is world state 0. This is world 0. And now we need to display world state 1, right? We want to render what the world looks like 30 milliseconds into the future, okay? But there's a problem. We don't actually know this value yet. Because we have a variable frame rate monitor and we're going to flip whenever we're done, we have no idea what the 30 milliseconds is. And most of this time is usually rendering. Like this is rendering right here, right? So the physics happens somewhere in here, it's got to know right away before we even have any idea how long the frame rate is. It's got to know how much to update the world by. How does it know to pick 30 milliseconds? Well, it doesn't. So it probably looks at the previous frame for a guess. Well, if it looks at the previous frame, it's always going to be wrong. It's going to look at 30 milliseconds here, but surprise, this took 16 milliseconds. So now you've got a world that appears to be moving twice as fast. Then we go here, we look and it actually turns out to be 20, but we thought it was going to be 16. So this is actually a world that appears to be moving slightly slower, blah, 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 right? So
basically you don't enforce the frame rate as is now. It just puts out whatever it puts out. Okay. Let's see what he's trying to say. Yeah, I don't like that either. But I don't know why I don't like it. I don't know. Where is main? FPS. What's this? I don't need this. Don't need this yet. Will it play the audio? Let me reduce the volume. Bring this down to 1. See, it doesn't stop playing. Yeah, sometimes it's like really high and other times it's really low. Weird. It's quite the difference. I wonder if it's because OBS is updating something. Ha. Okay. Glad I let it play. Audio drain error. Timeout. I'll leave it playing. I think I know what the problem is. Well, kind of. Because there's something I was considering. I mean, it's a bit annoying, so sorry. Make it quieter next time. Audio plays 1 second for each frame. That's too much audio data. Example, there's 200 FPS at times. During the same time, about 200 seconds worth of audio buffer gets filled. Okay, and audio drain. Yeah, it's just too much audio. Because the frame's finished a long time ago. But it's trying to finish playing the audio. Interesting. To-do list. Could also explain that. I'm not sure, but okay.
I do not understand. I do not get it. People who believe in this technology, please feel free to write in and tell me what the attraction is, because I do not see it at all. As far as I'm concerned, you need to know what you expect your frame rate to be in the future, and you need to guarantee that you're going to hit that frame rate in order to get a smooth, believable looking, non-hiccupy sort.
Also, let's say if the frame rate is variable, how do you play the right audio? Or like, how do you sync the audio to the frame? Because right now I have that problem, I guess. Where is it? So that's like 4 milliseconds for that one frame. So currently it's playing a second of audio. Each time this prints, it's the end of one frame. Yeah, I think my audio is totally wrong. I mean, not totally wrong, but yeah. Try game, update and render. Yeah, shouldn't fill the sound buffer every time, I think. Yeah. Alright. Anyways, gonna talk about that tomorrow. Audio synchronization. Figure it out then.
Sort of animation, unless you just don't care, you know? And so this, I think, is very important. So what I would say is variable update monitors might be useful if your frame rate, if you can guarantee your frame rate, but you happen to know it's always 45 milliseconds, let's say.
Hey Devnin. I don't know if you heard that, but I just realized I was making a grave error with the audio. Or maybe you would know something about it. Yeah. Well, no, I mean, I'll... no, yet. No, yeah, it still does that crackling thing. But I realized something else. See, every frame, this method's called game update and render. So every time a frame... Where's the frame? Yeah, a frame is rendered, the sound buffer is filled for 1 second. Which is wrong, because if I go back here, some frames only takes like 3 milliseconds, but every time for each frame 1 second of audio is written to the buffer. So I don't know how to do this, or is that okay? I mean, in that case, I don't... Yeah, I think fix the frame rate, but also I think probably don't need to wait for the audio to drain. Does this block? I gotta check. Pulse audio simple drain. Wait for the playback buffer to go empty. And I'm not amused. What do you mean? Oh, you mean you're not impressed? Well, I mean, in that case, it's a good thing you didn't switch from Rust to Zig for your project. Var versus const is totally not understandable. Okay, I mean, really? I mean, there's many other problems, but I wouldn't class as one of them. Checking if an entry is an array. Well, not sure what you mean. I mean, I think the var versus const, it makes perfect sense, right? A constant is a constant, like immutable. And I think it's enforced as well compared to others. And a variable is just a variable. I think that part, I think that kind of makes sense. Down, let me type it because I don't have chat open. I'm not going to type. Oh, stream manager. Yeah. The last two functions. A special character is keyword. Keyword 00, blah blah. I don't understand why outer. It's just a string, right? Slice of U8. This keyword checks if a slice of U8 is inside a slice of U8. I mean, is that even valid? Can you even have that? What's a special character? I mean, this could just be an enum, right? No, but I'm like, does outer get called ever? Hey, Monkey D. Luffy. Know when you want to use it to define them. I don't know. It seems like you're doing a bit too much work here. Devin, not gonna lie. But maybe I'm missing something. I think I did write Handmade. Oh no, sorry, wrong project. I did write Alexa too. Now I'm curious. Hey Monkey Luffy, I'm doing good. How are you doing? Okay, I don't know. I mean, this one's different. I never thought of that. I mean, I thought a slice of U8 is just, a slice of U8. Never thought it could be, what's it called? Another slice.
That would be pretty bad. So let's say it's something like 20. It's always 20 milliseconds. Well, that's fine then, as long as you're fixing that rate. But really, a variable.
And I bet I do. I don't know. Maybe. I mean, the outer. I really don't understand the outer method. This one, I lost it. Self-talk keywords. No. I understand the label, but I don't understand why. This bit. Okay, I'm getting distracted. I mean, I don't know enough. Let me check where do you use this keyword. Why can't I find stuff? Hey Jetro, what browser are you using? It's the Zen browser. Why is search so bad? Must be somewhere here. Line 63, thanks. What is contents? Slice of U8. Self-dub buffer. Contents to on slice. Yeah, I don't know. I don't know. It doesn't seem necessary. Maybe. I could be wrong. We should try without it. I got sidetracked. Alright, I'm gonna head back. You work in an open source project? No, I'm following Handmade Hero. Trying to build the same with Zig and for Linux. Yeah. Alright, gonna continue. Don't need this.
Refresh rate monitor doesn't actually help you during the course of your game. What all you really can use is something that's essentially a fixed rate monitor where you can set the rate. And so that I think is kind of mostly all I wanted to convey about that. Is I don't really understand the attraction of those things much at all. And I think if anything, they're only good because they allow games to run at other fixed frame rates that aren't 30, 60, 90, basically. Maybe you can get, you can use 70 or something. and maybe you couldn't do that before in any realistic way. So I don't know, just something to think about. Want to get that out there. So maybe I'm thinking about it the wrong way, but that's always been my problem with that whole concept. So for me,
It's for performance. I don't need to check the characters after the current character if the current character of the word doesn't match the current character of the keyword. Yeah, I mean, so you basically check the first character and then call outer to check the rest of it. Okay, that makes sense. But no, I mean, I said I don't understand in terms of when you said what's it called? Can, like, a slice, an element of the slice? Okay, gotcha. So you have some internally defined keywords and you want to check if what you are passing through or lexing through is the keyword. I think that I get, but I didn't understand what you meant before by when a member of a slice is a slice.
me, whenever I do a game loop and I'm looking at timing stuff, I always want to have a target frame rate, and we try very hard to hit that frame rate. And if for some reason we're not hitting that frame rate, we pick a new.
Yeah. I think, yeah, I know JS. I used to be a front-end developer a long time ago. Const includes my word. All right. But that would be a slice of U8, right? Or is it already that? Okay, how would you... Okay, so you want to check if your slice of keywords contains const U8. Now I want to check how I did it. Just a sec. Hey, you just started it, so I would give yourself... you should take it easy. It takes... I don't know, for me it made sense, because I don't like the way const is defined in other languages. Except maybe Go. I like Go's implementation. It's very similar to Go. Yeah, I mean, yeah, of course Go. I think Go is much easier. But I think different point, right? Yeah, you do got to use constcast quite a lot. I think I used it too. Okay, surprised. Thought I was... Because I think in the C library, nothing is const. Is it not? Where did I define my keywords? Which part doesn't make sense to you? I'm trying to understand, like, no, not that. No, not the EST either. Oh, maybe yes. Yeah. Work keywords is constitute, otherwise it's a compiler error. And then a slice of constitute in Zig is a string. It's the same representation as a string. If you're using strings, it needs to be a slice of const u8. Yeah. I think because strings are slice of const u8. And I think I read why it was, but I can't remember. And what, that just becomes a slice of bytes. I read it somewhere. I can't remember where. But that one I did have a problem too. But I can't remember. I read something somewhere and it made sense. Okay, I'm getting distracted now. Where's my... Hey, Monkey D. Luffy, I don't think so. Okay, I mean... I just want to check the keyword thing because it's bothering me now. Oh no, I'm looking in the wrong place. Oh, maybe it's in token. Oh, what about standard mem.equal? Did that not work? I'm guessing this is what you're trying to do, right? Maybe. I'll just leave it in the chat. Should maybe pop this out. I don't know. I shouldn't have copied the code. Should have just linked to the file. Here. Yeah, there we go. Where was I? Yeah, I mean, it's only first day, but okay. I mean, I do follow your sentiment. Like, some of the things are quite confusing. The const UA thing is one of them. Because for a long time I didn't know strings were that. But some reason it makes sense. Because I think in Zig you also have, you can have slice of U8 which are not null terminated. I guess. I don't know. I don't exactly remember anymore. But something about it makes sense. But I don't know what. WTF8. What is WTF8?
Do lower frame rate, and we're always trying to stay fixed at whatever that frame rate is. So if we're trying to run at 60 and we can't run at 60, we drop down to 30 or something like that. And again, maybe that's where, you know, these variable frame rate models could come in. They allow us to change our fixed frame rate. But I never want the frame rate to be variable. I never, ever, ever want that, because there's no way to actually make that work properly. Your physics is always wrong if you do that. So what I want to do is
wobbly transformation format. That's funny.
I want to make a frame loop that basically obeys this sort of thing, where it's going to have an opinion about the frame rate it can hit, right? So it knows how many milliseconds that is. We'll call that the target milliseconds. So we know what our target milliseconds is, right? The target millisecond comes in, the physics updates the world, right? So we get our update here. It's the target milliseconds drives our update. We do our render.
Oh, I think one of the things I do remember when using standard memory, I think it always expects a slice. So the type is just the type of slice it is. So let's say you want to compare two strings, slice of const UA. You pass the underlying type like U8 and then the two const U8s, I guess. There's also equal strings, I think, if I remember correctly. Or maybe that could be in the test. Equal. Yeah, it's in the testing. Because I think equal strings, yeah. Okay, never mind that one. But I did copy some of this code to write my own.
And then we do our page flip of that render right as close to the boundary of the target milliseconds as we can, right? Then we do the same thing over again for the next thing. And now this may be pipelined, so remember this may go off to a GPU or something, which actually delays everything by a frame while it chews through it or whatever. That's fine as long as we are always pushing it at a synchronous thing, and we set it to synchronize, say with the vertical blank or whatever, that the monitor refresh. We'll still be just fine as long as we always.
Yeah, and then in the last update, they removed a sync and then rewrote. What was it? Yeah, the IO read and write. There were quite a few break changes, but I think it could be soon 1.0. I read maybe after they do the async stuff, it might be 1.0.
Always know that we're updating with a particular target in mind, and that target matches our flip rate, and that is what we're trying to do. Now for the audio, we have a slight other problem here. The problem with the audio is, ideally what we'd like to do is feed just exactly the amount of audio that we need every frame. But if we do that, we do run the risk of, if we miss, like let's say we missed for our 30 millisecond time, right? So we actually missed and we're going to have a frame lag. Well, our audio would skip here. So we have two choices because we basically need to make sure the audio is always there on time. We have two choices. Always get the audio there on time, meaning our frame rate is a hard constraint, and we've basically written the game to never miss frame rate. The other one is always feed the audio somewhat, as long as we always know that we're updating with a particular target in mind and that target matches our flip rate. And that is what we're trying to do. Now for the audio, we have a slight other problem here. The problem with the audio is ideally what we'd like to do is feed just exactly the amount of audio that we need every frame. But if we do that, we do run the risk of, if we miss, like let's say we missed for our 30 millisecond time, right? So we actually missed and we're going to have a frame lag. Well, our audio would skip here. So we have two choices because we basically need to make sure the audio is always
man kan till film using a version of Ubuntu
there on time. We have two choices. Always get the audio there on time, meaning our frame rate is a hard constraint, and we've basically written the game to never miss frame rate. The other one is always feed the audio somewhat further ahead. And there's two methods of doing this. One method is just to be a frame of lag off, right? Or something, or half a frame of lag off, right? In order to handle a whole frame miss, you kind of got to be a whole frame of audio ahead, right? So that would incur 16 milliseconds or 30 milliseconds, depending on the frame rate. This is at 60 hertz, and this is at 30 hertz. I should probably start saying 17, because it's 16.6 repeating, right? It's 1,000 divided by 60. But you know what I mean. When I say 16, it's code word for 17, 16 and a half, whatever. You know what I'm saying. Anyway, basically what happens here is I'm introducing audio latency, so I could try to reduce that audio latency by doing one of two things. One thing I can do is always feed 2 frames of audio, but when I do hit my target, when I do find that I wake up and I've got plenty of time to update the audio, so I'm here and I go, okay, I've got plenty of time to update the audio, update it as overwrite the old stuff that I wrote, right? So basically, always give it an extra frame, but don't use that extra frame if we have time. We'll just splat a new one, right? That's one way of doing it. Another way of doing it is, like I said, to just always actually write one whole frame ahead. And a final way of doing it would be to have like a thread or something that's sitting there waiting, and it looks to see if we've updated by like right here. And if we haven't, it emergency flushes another frame of audio, right? So it's kind of like a guard, right? So we've got a couple options. We've basically got one, always hit, we've got always hit the frame rate. We've got overwrite the frame, overwrite the next frame. We've got a frame of lag, and we've got a guard thread. And there may be even other methods. Those are just the ones that I happen to know about and have ever seen used or used myself. So I'm not 100% certain that I can honestly argue directly for any one of these in particular. It's kind of hard to say. I think the one that I would rather go with, because it's simpler and it
Yeah, sure. Well, what do you want to ask?
Forces sort of a little bit of discipline, would just be going with option 1. Option 1 is the easiest option, is to always hit your frame rate, right? And one of the things that's interesting about that I like is I like the mentality of saying that this game has to hit its frame rate instead of just allowing it like, oh, it kind of gets slow sometimes and we don't want to optimize when the explosion happens or whatever and it gets slow, so we'll just let it get slow there and we'll compensate by having the frame rate looks crappy but the audio doesn't skip, so we're happy, right? I don't love that. I feel like if we write a game and the user is being reasonable, so they're playing our game and not running like another game in the background or something where they deserve to hear some audio skips if that's where they're going. I would prefer kind of to say we always hit our frame rate. So, we target 30 hertz, let's say, and we always get there. And if we don't hit 30 hertz, then that means we have to optimize whatever it is that's making us not hit 30 hertz. So I'm tempted to go with this one first. I think that might be which one I go with first, but I wanted to mention these other ones because maybe we'll have to switch to them if we find that we're unsatisfied with what I'm talking about here. Or you may choose when you're implementing this basically to go with a different option because you care about different things. Because
Yeah, but I think I'm kind of forced to use the thread. Because the right audio blocks. But I just realized something as well. I gotta write another note. Where's my... Only... Fill the buffer. Sound... F4...
many things in programming, there's not a right answer. There's simply a question of your priorities, and those priorities will lead you to make a certain decision or a different decision. And you can't really say that the decision was wrong or right. You can only say if it was wrong or right based with respect to some priority system.
The frame times could be different, like one frame takes 60 milliseconds and the next one takes 20. I think that's what he's trying to do. Like he's enforcing a frame rate. "17-year-old preparing for career in cybersecurity. Right now I'm working with Arch Linux and customizing my distro through Rising, but I'm stuck. Is it really worth it? I see your system is. I mean, what do you mean Rise? You stuck with the Rising? I mean, I don't really care much for Rising. I just put a theme on GTK. That's all I did. I saw this a few days ago. Have you tried this one from DHH? Yeah, I think this one's also art. You could try this one. And he set up everything already. I haven't tried it myself. But it looks pretty cool. You could try that. So you don't need to write it yourself.
So there you go. Hopefully that makes some sense. So we need to do a couple things that we're not doing right now in order to make this happen. The first thing that we're going to have to do is we have to figure out some way of knowing, or at least getting some idea of what the monitor refresh rate even is, because we want to run at that refresh rate. And so we kind of have to go ahead and take a look at at ways to figure out what the refresh rate is of the monitor that we're actually using. Now, to be honest, I haven't done this in a long time, and I did write down some notes about how I used to do it, but it's going to be a little dicey, and the reason for that is I don't really know all the stuff that happens, essentially, with multiple monitor scenarios. So if you take a look, basically here's the thing that I was thinking about. You can actually see get monitor refresh rate. Let's just take a look here. Where is our MSDN? MSDN, here it is. Let's take a look here. I'm pretty sure that some of these are just not actually, well, okay, this might work. So this might actually work because it does take the HDC. So we'd be able to pass our Windows device context handle. And let's see if this is going to be something that we think is a reliable value. I don't actually know if it is or not, but we can sort of see. So here we go. The current vertical refresh rate of the device in cycles per second. So basically this, a vertical refresh rate value of 0 or 1 represents the display hardware's default refresh rate. So that's not really useful, right? That's not going to tell us. We actually need it to say something like 60 or something like that. That's if it's just going to tell us something nonsensy like that, that's not going to help us. So we can enumerate. We can also enumerate the monitors, try to find it from there. I'm not entirely sure. I'm not entirely sure what the best way to do it is nowadays. This is a good question, and I'm not super prepared to answer it.
What do you do with X11? Windows system get monitor refresh rate. No. X11 method. Maybe. I forgot what it was called. Oh yeah. Function index. I do remember stock being quite hard. Yeah, developers guide. Okay, there's an extension. It also be a game logic which needs to do more work, which doesn't fit into the time window. Oh yeah. You mean like, how would you do it if 2 frames don't take the same time? Yeah. I mean, I think that's what I want to find out. Interesting. Can you just use it this way? How do I know if it's installed every time?
So yeah, I don't know. I don't usually trust the Stack Overflow answers. I found them to be wrong a lot of time, so I don't tend to look at these very often. And this doesn't look particularly convincing here either. So I don't know. I'm going to go ahead and say that I'm just going to go with enumbing the monitors. This is the kind of thing that I do nowadays, and I haven't really played around with refresh rates too much. But I just want to kind of, I feel like this might be the most useful way to go, because I think this will probably give us a way to get it. So I'm going to take a look at this. Basically, enum display monitors is a thing that allows us to see basically all of the things in the system that are monitors that can be displaying graphics. And I believe we can do a pretty easy way to actually get the one that we're on as well. So let me take a look at this. Then when we call get monitor, we can call get monitor info on those, and I believe that sort of thing will be able to allow us to ask for stuff about the refresh rate. I'm not actually sure that that's actually true, but I think it might be. So let's take a look here. Monitor info. Yeah, we can. Let's see. Still not the case. Let's see. Get refresh rate of H monitor, because I'd really like to be able to do it from here if possible, because I just don't actually trust the other thing. Yeah, so you can. Yeah, I don't know. I'm sorry I'm hemming and hawing so much here. A lot of times these things are pretty crazy. So basically, excuse me. It looks like this device mode structure here would actually tell us what it is we want to know. So let's just see if we can get one of those relatively easily from the monitor, and whether that gives us back, I'll just test it, whether it gives us back the actual information that we want. It looks like it probably would. So let's take a look here. Height, display frequency, right? So is that defined? Let's see what MSDN says. Again, MSDN can definitely be wrong, but it's usually my first go-to. I trust it more than Stack Overflow anyway. So let's take a look here. Frequency. What that basically says is this value is also known, blah, blah, blah. When you call this may return with value 0. What is with this 0 and 1 thing? Well, all right. I guess I'm not sure what way I can really definitively say what the monitor refresh time actually is. It does not seem to be something that's forthcoming. So I don't know.
Hey, you have a good one too, Devlin. Thank you for hanging out. As always.
No, that's kind of disappointing to me. Normally, so I mean, just to be clear, the reason that this doesn't normally come up is normally what happens in OpenGL or Direct3D is you set them into a mode where they flip on the monitor refresh anyway. So when you do that, all you have to do to figure out what your refresh rate is time how long it takes to flip in one of those two things, and then you roughly know what the graphics card is doing. That's pretty straightforward and not that difficult. But in this case, if we actually want to know, because we're doing the flip, we're doing the blit ourselves, so we don't really have that freedom. The way you would used to do it is with direct draw. But direct draw is kind of old and deprecated. I don't know. We could try to do it. Direct draw, get vertical refresh. This is the way that I used to do it in the old days. We could try to do it. I don't actually know whether that will be sort of whether that will actually be accurate though when we ask for a particular monitor's vertical refresh. So let's see.
I'm just gonna skip that.
Is we're going to have to assume that we make up a refresh rate. And so for now, we'll say that there's a refresh rate up here. We'll say that this is a refresh or monitor refresh hertz, and that will be just 60 for now, right? So we'll just say it's 60 refreshes per second. And we'll say to do how do we reliably query this on Windows? Because we don't know. Maybe direct draw is still the way to do it, which would be kind of scary because direct draw is deprecated. So that would not be my preference, but what are you gonna do? All right, so then what we can do is from that we can compute some synthetic values, right? We know that from that we can compute how much time we expect to go by in seconds for every frame. So basically the seconds elapsed per frame, right, is going to be the milliseconds, 1,000 milliseconds per frame, divided by that monitor refresh hertz, right? That's going to give us how many seconds are elapsed every frame. So I guess the other thing we should say is we have a game update hertz as well, right? And I sort of was saying that we probably don't want it to be the monitor refresh rate because we're going to not probably hit 60 when we're doing software rendering. So maybe let's say this is 30 as well, and basically we'll derive this from this once we actually get to some place where we can get this value. So for now we'll say it's that divided by 2 or something like that. So really the second elapsed per frame is actually going to be our game's update hertz because we'll probably be only flipping every other time. So that's how much we want to actually have elapsed. So the first thing we need to do is actually measure this, which we already kind of put in the basis of, and then we want to actually wait until we get to the point where we're at this time elapsed, and then we can go ahead and sort of delay, if you will, our page flip to just the right time so that we get 60 frames a second. Or in this case 30 frames a second, whatever our game updates hertz is. So what we want to do is down here somewhere, right? After we've done everything, remember we have a thing, we already kind of put a thing in here where we query performance counter. So we know how much time has elapsed, and we were printing that out before. We were printing that out right here. So we basically have a value, which is the counter elapsed, and we actually did the milliseconds per frame thing here. And so what we want to do here is change up what we're doing a little bit. What we want to do here is say how much time has actually elapsed so far, right? So seconds elapsed for compute, basically, for work, let's say, how much we actually had to do. And we know what that value is. That's this right here. So we're going to go ahead and do that. And that's just this particular thing. We don't actually care about this, the 32-bitness, I'm sorry, the 64-bitness of that, because we've already done the subtract. So that's all good. So once we do that, we basically have, and we don't need the 1,000 anymore because that was to compute milliseconds. So really all we need to do is divide the time that elapsed by the frequency of our clock, that Windows reported for our clock, and that will give us back how many seconds elapsed during the work that we did for our frame, right? Now what's going to happen here is that's going to be different than the other value, the value that we basically computed up here, which is how much seconds we want to elapse per frame. So this is the seconds elapsed per frame target. And we could actually call that target seconds elapsed per frame, or target seconds per frame, something like that, right? So we have a target seconds per frame, and we're going to see like basically how much time we have left. So assuming we're always trying to be under it, right? So we're assuming that we essentially have, we almost want to have sort of a while loop here, right? We want to kind of say while the seconds elapsed, we could even think, yeah, in fact, I'm going to change this back to so far because we could just go ahead and, no, you know what, because we're going to want to print that out. Never mind, I'm going to save it that way, that was good. So I'm going to do seconds elapsed for frame, right? And we'll start that off by saying we're going to actually be doing this query performance counter. We're going to be doing this actually inside a loop. So we're going to take a look at the seconds elapsed for work. We're going to say that we're going to start with that, and then we're going here and say if the seconds elapsed per frame is less than what we actually wanted, so if it's less than the target, right, then we're going to take some action to basically make sure that we are not going too fast. So we're basically going to slow things down. So the first thing we can do, and this is just the CPU melting version, is we can just do this again, right? We can just go ahead and full on do this sort of thing. Now you can see that this is going to start to get messy if I keep doing something like this, where I keep, I keep checking and checking and checking. So we're going to probably want to pull this out in utility function, but for now, we should probably be fine. So what we'll do is we'll just keep getting the end counter over and over. We'll look at the counter elapsed, and then we'll basically do the seconds elapsed for frame computation. We'll just do it inside this loop, right? We'll just keep on doing it and doing it and doing it. And so what we should do, oops, don't want to define that again. What we basically should do here, and you know what I can even do, I don't even need to do that. I can just stick that right in there. There we go, and make that divide a little clearer. There we go. So basically what we can do is just keep on doing this, and until we get to the time when we actually get above the target seconds per frame, right? And then we can go ahead and do our flip. So in theory, if we actually do that now, in fact, we should actually, that should actually just be basically a locked loop that forces us to update at 60 frames a second. Now we'll have to verify that that's actually true, but let's just go ahead and make that happen here. Where are we? There we go. Let's see. Why am I not... Why am I not getting any input here? That does not look reassuring. I feel like we should be getting some input, but we are getting no input whatsoever. That doesn't sound good. Something has gone horribly, horribly wrong. I suspect that probably this while loop was busted. Hold on one second. While seconds elapsed per frame is less than target seconds per frame. Nope, that should be... What did I do wrong? It was off to a good start in the stream today when the first thing I type in is already lousy. But you know, programming's like that some days. Some days you're on and some days you're off. And on days when you're off, it just means you got to do a lot more debugging. And you know when it happens. But you know, what can you do? You gotta chin up, you know, and get through it. Anyway, let's go in here and step in the debugger. Hopefully it'll be relatively obvious what I messed up there, because we're not actually updating. So I think what's happening is this while loop is never actually making this get big enough for what it should be. So, oh, well, that was easy. It looks like we left yeah, that's good. That's stupid. All right. What I basically did there is I computed the target milliseconds per frame instead of the target seconds per frame. So that's pretty much the entirety of the bug. Not particularly interesting, to say the least. So, okay, in theory, we should actually be going at somewhat more of a consistent frame rate, but I don't actually know if that's true. We should be going at 30 now, but I'm not sure if that's true. That audio is skipping like crazy, so I'll have to take a look at what's going on there. So let's take a look here at that while loop, make sure that's actually running properly. Oh, so this is wrong as well. So this...
I guess, is that why? Where is it? Write another note. This needs fixing. How do you get skipped in between frames? There's 1 second of audio and about 30. What was the frame rate? Yeah, between 30 and 20. 10 milliseconds. Render frame. That could explain why it makes that noise. Yeah, because it gets skipped. Okay, there's a few things to fix.
End counter has to actually be done outside. So let's go ahead and pull. I don't know if you could see what was happening there, but basically we need to update our last counter to be proper. I mean, the fix is very simple. It's this right here. But this code is now super messy, so I'm going to go ahead and pull that out. Let's see if that makes it a little bit better. Okay. Yeah. So that looks more correct. All right. But this is still super ugly here, so we got to pull this out. So let's start by pulling out this the clocking stuff into something that's a little more understandable, right? So let's basically say, first of all, I kind of want to go ahead and say that the query performance frequency, this thing right here, I kind of want the query performance frequency to basically be something that can be always accessed. Since we compute it once, I want that to be just like a global variable that's just whatever the frequency is, and we initialize it at startup. So what I would like to do, at least, is have this variable basically, right? I'd like this to be a global. So I'd like that to be a global variable. So the perf count frequency is basically going to be this thing here. Let's see that we had it at before, perf count frequency. So basically, we just want a global variable that always lets us know what that frequency is, so that we query it once and then we can use it outside in a different context. And so then what we have is we basically have our excuse me. We have our actual call that does our computation. We want that to be something that's kind of nicely encapsulated, so I'm just going to pull it out here, and I'm basically going to have a way of saying snap a counter in various places, and then take a difference of them. So basically, I want something here, which is basically, it's just an inline function that's going to do get seconds elapsed, something like this, and it will take two different ones of these. So start and end, let's say, like that. So it'll take the start and end, and it'll do this computation properly. It'll know that basically whatever the elapsed time is here, it'll do end dot quad part minus start dot quad part. It'll do this reliably, so we know we don't have a typo or anything in it. We can debug it once and make sure it's right. Basically, we'll just do that seconds elapsed. It'll do that computation and then return it. So there we go, like that. So that's fine. And then we also will have one which is basically just a way to get a clock value. So win32 get wall clock, basically, that will actually do this query performance counter and just return that value directly. So that way, at least we can see it's a little clearer what we're actually trying to do with it, and we can go ahead and return that. There we go. So now we can replace our stuff with this, and hopefully it will all be good. So perf count frequencies there. Let's go ahead and put this up with our globals, and we'll call that global perf count frequency. So perf count frequency. And that should never change during the run of our program, so we should be good to go. Now, in here, we need to replace our all of our stuff that we were doing for query performance counter. What we actually want to do here is say, okay, our last counter is equal to win32 get wall clock, right, like that. And we can leave our RDTSCs for now. We're going to do something else with those later, but RDTSC is very processor specific, so you can't really use that for timing. You can't use that for timing that runs on the user's machine. You can only use query performance counter for actually timing stuff on the user's machine. So our game code has to be driven off of query performance counter. RDTSC is only for timing code for profiling, because how it behaves varies from CPU to CPU and all sorts of other stuff. So you don't want to ship a game that uses RDTSC for actual game time. All right. So then we get down here, we can say this is basically our work counter. So our work counter, win32 get wall clock, we'll get that there. Then we have, that was our cycles. That can go up there till we deal with it later. So we have our work counter there, and we want to know our seconds elapsed. Let's just call this work seconds elapsed, like that. We can say win32 get seconds elapsed, and we'll give that between our work counter, basically, work counter, and our last counter. So that's the actual last counter that gets updated at the very end. So I think that's roughly right, what I want to do. Then I'm going to go through here, and this is going to be our work seconds elapsed, right? We're going to go through here and say we're going to update our check counter, basically, and that's going to get the wall clock time here, get wall clock, like that. And then we're going to get the seconds elapsed, win32 get seconds elapsed, and we're going to try to...
Damn, he's going too fast. Don't even know what he's doing. Let me have a look. How do I get FPS? Time per frame. I guess that would be the wall clock. Maybe. Okay, so it goes start time, end time, time per frame. So I just gotta add this while loop.
Time in between the last counter and our check counter, right? And we can also just basically do this, right? Which is kind of nice. Having functions encapsulate our stuff is nice because it just makes the code so much more readable, right? So we can basically just sit here and keep going. In fact, we could even be even more ridiculous if we really wanted to and put that expression right here. But I don't think we need to go that far. That doesn't seem useful. So let's not do that quite yet. Anyway, I'm going to if zero out all these things for now because we're not dealing with them at the moment. Then at the end here, at the very end, we need to update our last counter. So basically what we can do is we can say that our end counter here, large integer end counter equals 132 get wall clock, which is what we wanted. And then we can set the last counter equal to that. Now this guy here, I'm going to leave all these guys together and stick them down at the very end. This stuff needs to probably be cleaned up a little bit, but yeah, let's move all that down there. Okay, so that should be about right. I think that looks about right. Now, of course, the problem is at the moment we don't really have a good way to tell even whether what we're even running at. Like we have no actual way of knowing what our actual frame rate even is, and so that's a little bit of a problem to say the least when you actually look at it. You know, does it look consistent now? Oh, you know, sure, right? But how do you really know? And so what we kind of want to do is probably have some way of actually trying to verify that. And one thing we could do, and I think this is probably what we should do maybe in the remaining time, is put a little counter that just goes up every frame that we can actually time with, you know, like a stopwatch or something, and verify that in like a minute's worth of time that it has actually gone up by the amount that we should think that it should, right? By, you know, 60 times our frame rate, so 60 times 30 or whatever it is. But maybe, I don't know, maybe we'll do that tomorrow. We're getting kind of low on time here, so let's just keep going with what I was talking about here. So what we do want to do is we kind of want to say here, even though this is while loop will work just fine, there's a couple other things we want to do here. First of all, excuse me, what we do want to do is we want to actually verify that we didn't miss a frame. So in the if seconds elapse, what we'd like to do is put an else at the end of this while, right? But you can't actually do that in C. So what we want to do here is say, okay, if the seconds elapsed per frame was actually higher than the target, then we've got a problem, right? Because if it's actually a little bit higher, that means we missed our frame rate. So this is something we want to do here that says missed frame rate, you know, that's that. And we could even do an assertion here. But the problem is the assertion would lock up. So what we'd really like to do is this will be a thing that will log, and we'll be able to see that actually pretty soon. I don't know if we'll do logging next week, but pretty soon we'll be able to start seeing some of these things that we wanted to log, but we don't have a system for yet. So the other thing we want to do is this will basically just melt the CPU, if that makes sense. Basically, even if the CPU did all the work that it needed to do for the entire frame in a millisecond, it's still going to sit here in this spin lock doing a ton of work, constantly checking the performance counter, right? It's just like wasting CPU time. So what we'd rather do is we'd rather see if there's any time left that we can actually use to just sleep. Just tell the operating system to put the CPU to rest or do other work that it has to do. So what we'd like to do is use this command from MSDN, sleep, which basically, excuse me, which basically just takes a number of milliseconds and it waits. It basically just waits for that number of milliseconds. So what we would like to do
you just sleep for the difference, I'm guessing.
Here is basically say, let's do that sleep for the milliseconds, you know, sleep milliseconds basically, right? And so in here we're going to say that we have a sleep milliseconds, and the sleep milliseconds is going to be how many milliseconds we could afford to sleep, right? We're going to say, all right, we'll take the target seconds per frame, okay, like that. We'll take the seconds elapsed per frame, we'll subtract them, right? Why did that not copy? There we go, seconds elapsed per frame. We'll multiply that by 1,000, right? Because this is in seconds, and now we've got milliseconds, and that's how many milliseconds are left, right? That's how many milliseconds are left to wait. What we want to do now is that's going to be a fractional value, obviously. Excuse me. And so we only want to, we basically want to truncate that, if that makes sense. We want to sort of, oh, you know what I forgot too? I forgot this right here. There we go. We need to actually wait to display the frame. This would actually have displayed the frame and then waited, which is not particularly useful. So what we want to do here, is we want to go ahead and see how many milliseconds we can sleep. So to do that, we're going to go ahead and truncate this fractional value. We're going to truncate the fractional value out to a D word after we compute it. And so that will give us how much we can sleep, and then we will sleep. Now there is a huge problem though with doing this, unfortunately, which we probably won't see when we run it here, but it's there. You'll just have to take my word for it. Oh, well, you can kind of, yeah, you can, no, you can't really see it. And it's something that it's hard to see when we don't actually have something running, and when you're not in certain circumstances and whatever. Because there's a whole bunch of stuff that ties into this, but we'll get to those in a second. The problem is that basically this sleep function in Windows has a certain granularity with how long it can actually put your thread to sleep. So if it decides when you call it that it's going to put your thread to sleep, meaning your thread will no longer be executing, it is going to wait for the next scheduler granularity to wake you up. Now what that means, for those of you unfamiliar with operating systems, is inside every operating system there's some code called a scheduler, and a scheduler is what decides when threads run, like when different processes run, when the threads run. It's basically the thing that makes your operating system preemptively multitask. It's the thing that lets you run a bunch of different programs at once, and it doles out the work, it doles out the CPU time to each of these programs to allow them to do the work, right? But what happens is that scheduler basically has to be sort of a thing that interrupts what's going on. If you imagine you have one program running and you need to let the CPU do some work on another program, then the operating system, you imagine, has to like interrupt, right? It has to jump in and say, okay, stop the process, hold on, that you're doing, like Emacs, let's say. Stop Emacs, hold it. I gotta go run the code for this timer overlay that Casey wrote, right? Or something like this, if that makes sense. So if you think about what happens there, however frequently that scheduler wakes up is the minimum amount of time you could sleep for. Because if your thread goes to sleep, it's not going to wake back up again until the scheduler comes back on the CPU and looks to see and goes, oh, he wanted to wake up in X milliseconds have elapsed, so I'll wake him up. But if the scheduler only wakes up, let's say, every 15 milliseconds, and you ask to sleep for 2 milliseconds, well, you're actually going to sleep for 15 milliseconds because the scheduler ain't going to wake up every 2 milliseconds and look.
Yep.
Excuse me. So we can fix this. It's not a perfect fix, but we can fix this. We can fix it with something called time begin period. Now what time begin period is, it's a weird... I don't even want to know how this ended up being the way to do this. You can sort of see how, but oh my lord. You would think there'd be something called set scheduler granularity, but no. What actually happens is time begin period is like an old multimedia system call for setting when you would get callback timers and what.
Wait, I'll do that. I'll look into it. I'll look at it after. I think I will set for now. Let's call it target. PS is 60. Yeah, and then hang on, let me write down what we need to do. Check. Get current FPS. Check if within target FPS. Not sleep. Otherwise, render frame. Is that it? Sounds a bit too easy. Okay. I think I'm missing something, but okay. Okay. Start. think there was something. Oh, let's see what else we need. Where's game here? So I guess I could move this up here. Excuse me. And this should still be here. Because renders the frame and then the next frame starts, I guess. Time per frame is end time minus start time. Guess instead of target FPS, I guess target, because I don't really need FPS. I just need to know the time. Frame render time. I don't know. 60 frames a second, so my time is in milliseconds. Seconds. So just 1000 by 60. Guess that makes sense, right? Frames per second. If I want time, I do seconds per frame and times millisecond, I guess. Excuse me. And time. I'll leave that there so I can print it. While time per frame is less than. Target. I should probably have a smaller name. Good. Target frame render time. Yep. Minus time per frame. How do you sleep? I'd say the Firefox search sucks. Quite bad. Standard time dot sleep. I don't think it exists anymore. It's per day, minutes per week. Red dot sleep. Spurious wake-ups are possible and no precision of timing is guaranteed. It's nanoseconds. If milliseconds divided by 1000. that work? Save build run. Signed integers, you must use div trunk, div floor, div trunk. That went terribly wrong. Okay, frame render time and time per frame. Oh, because I see why. Don't update time per frame. Thread asleep and then time per frame equals I'll clean this up in a bit. Okay. But the FPS doesn't match. Gets it almost right sometimes. But at least it's more consistent. Sometimes it's really slow though. Should really clean this up. Maybe yes. I think that's better. Can I just use nano timestamp? No, it's a big number. I'm gonna use that. I think I could move here. Rid of that. And these are all like wall clock time. They're not cycles per frame. Gotta go back and watch it again because I think I missed something. Looks a bit wrong. Target seconds per frame. What if I brought this down to okay. Is that exactly 30 every time? That is cool. think this could be target milliseconds per. That makes more sense. Quite surprised that it can hit 30. That's pretty cool. I like that. Let me just check if I'm printing the right stuff. Send a debug print, target FPS, PS, time per frame. I should really print this here. Because I'm guessing this takes some time. Time dot milli time stamp. Yeah, it is a little bit off because it takes some time to render the game. I guess not too bad. $60 seems to be okay. Not really. Still around 30. Yeah, we'll leave it at 30 for now. Then where is platform read? Here. $39, and I also want to see target millisecond per frame. Oh yeah, I missed. I mean, it's quite close. That's cool. I could adjust it a little bit. Find out how long it takes to render the game. And I can offset this time based on that. Hey Sham. suppose that could work. Damn, it's been nearly 2 hours. Interesting, the render actually... Oh, I'm following Handmade Hero. I'm on day 18. Oh, okay, gotcha. But I could separate the two. It returns nothing. Yeah, I think this should be outside. Yeah, so this should be somewhere here, and then the game can be rendered. Let me do that. So it kind of feels like Rust. I think it feels more like Go. But, well, I haven't written any Rust, so I don't know. It's about here. Oval keyboard input. Yeah. I think it's streaming on both Twitch and YouTube. Screen buffer. Do I pass it the actual buffer? Off screen buffer. Don't need that. Don't need that. But doesn't it need the sound buffer? Oh, okay, because it it systematically uses the global sound buffer. I think that makes sense. Guess just use it for now. Global sum buffer. Twitch's community of devs. Zig is rare and people like me dig it. Yeah, I quite like it too. I've been enjoying it quite a lot. This is the wrong buffer. Then global off-screen buffer. Yeah, I think this should be more accurate. I should clean this up really. Maybe. For now it's fine. I think it's quite obvious what it's trying to do. Expected 7, found 9. Why do you use NVim? Is it practice or kind of picked it easily? Tried but failed many times. I mean, it's been a long time now, so I think what I did was, what's it called? Maybe I can open a new one. And then you go, I think it's Vim Tutor, still here. Tutor. Yeah, I think this is how I started. It's not very long. I mean, okay, it's a bit long. But you can do, I think, the first 10 or 20 chapters. And there's also like, you can practice it at the same time. I think I've been using it now for 5 years, 4 years. I think the first month was difficult, but after that, you kind of get used to it. So even maybe the first 2 weeks, not the whole month. Run the game. Screen buffer, sum buffer, display window GC. Guess it doesn't need the input. Oh yeah, because game memory is for the renderer. This goes there, this goes here. Audio pool, display, keyboard input no longer necessary. Window GC, okay. Okay, that's much better. It's a lot closer now. That made sense. This kind of, I think, could be done better. Does dip trunk take care of if runs towards 0 for unsigned integer? Okay, caller guarantees denominator not equal to 0. So you kind of have to check that. Not equals to 0. Yep. Six. Yes. I think they'll do for now. I didn't think I finished the whole thing. Implemented sleep. I do need to refactor this. I think if time per frame is 0, something's gone wrong. Gotta fix the audio, and I noticed the output looks weird. And I gotta fix sound. I think that's tomorrow. There's a lot of problem with sound at the moment. Gotta handle that. Still not too sure about this one. I could move this whole thing into a function. Maybe. I'll have other to do. It's fine. Yeah. It's already quite a lot of to-dos at the moment. Set frame rate. Get rid of that now. Transient memory unused. Yep. I think it'll be used at some point. Gotta get monitor refresh rate. Get current store. Static linking for sound. And this one, I think I'll deal with this tomorrow. This is the first point. Think, action, tomorrow. Okay, I think I'm gonna call it, oh sorry. Can you use for any languages? And I believe you can get, sorry, I missed your message. That was 5 minutes ago. Yeah, you can. Yeah, I think you can get an LSP. And you can also get autocomplete. Yeah, I switched off autocomplete last year. I mean, it was too annoying. Not annoying, but I prefer not to have it. It was just an experiment. But you can have autocomplete. I used to have it for the first 3 years. Or 4 years. Or 3 years. I don't know. 4 or 5, 3. And you can, yeah, you can use it for any language you want. I use it for Go, well, and Zig. What else do I use it for? I think some JavaScript here and there. Okay, I think I'm gonna call it a day there. Okay, I gotta add another to do. What about that? Sleep. Scheduler. Let's see. It's fine. It's not urgent. Okay. Thank you for hanging out. As always. Shall see you back here tomorrow. Hope you have a good day. See ya.